Hello everyone, welcome to AWS and Linux Foundation course. Today the agenda is to talk about logical volume management, which is LVM, right? So let me take this agenda. We will talk about the logical volume management, physical volume, logical volumes, volume groups. So these are the different components that we are going to discuss within the logical volume management, right? Well, so let's see, why should we be using the logical volume management at first place, right? So if I go to this particular slide, right, well, team, we have talked about the file system concept, right? The file system concept will help us to store the data in the specific volume that is attached to the EC2 instances, correct? So we talked about that when there is a volume is associated to the EC2 instance, you can use the volume as it is by formatting the volume, creating a super block structure, and mount the volume into any specific directory and can start keeping the data over there, correct? That way, whatever the volume size, your file system size will be the same, correct? If in this presentation, right, you see that there is a SDC volume of 100 GB. If you create that 100 GB volume as a single file system, you will be getting 100 GB file system space, and that specific mounted directory you can keep 100 GB of data. That's how the things work, right? The second scenario that we talked about, right? It is possible to create a partitions out of the single volume, and each partition can format and can mount as a separate file system into a separate mount point, right? In the second scenario, as you see, right, the 200 GB volume is actually got divided it into multiple partitions. One is of 50 GB in size, one is 150 GB in size. Each partition can be formatted and can be created as a file system and can mount as a directory. What is the use case of me going through the partition model? If in case I would need two different file system to store the data of two different business applications, right? Then if you have a bigger disk with you, it's better to partitions, make a partitions and create a partitions it into a specific dedicated custom file system, right? That's the use case why you guys has to create a partitions from the disk, the two use cases. Now let's talk about the third use case. Let's say in your system you have a couple of volumes associated, obviously, right? A EC2 instance can have multiple volumes as well. As a scenario, right? Assume that you got 100 GB volume, 50 GB volume, 200 GB volume. There are three EBS volumes that are associated to your EC2 instance. Now, if you go to your EC2 instance, you should be able to see these three volumes. Now, my requirement is, let's say, I would like to create a file system. You know, right? What does it mean by the file system? The file system is the mount point where you can store the data, right? I would like to create a file system of 150 GB in size. How it is possible to create a single file system of 150 GB in size? Because as per the first scenario, the whole volume size will be equivalent to your file system size. In the second scenario, the bigger volume can be splitted it into multiple partitions, right? Ideally, if I need to create a smaller file systems, it's better to go with the partitioning concept. But now the requirement is I would like to create a bigger file system than the volume size. You know, let's say I need a 150 GB. Let's say I need a 250 GB, right? The biggest volume itself is the 200 GB, but how can I create a 250 GB volume? Correct. So that is where I need a flexibility. Correct. So I need to use the logical volume management concept, right? What the logical volume management is doing here, right? In order to start using the logical volume management concept to create a file systems by using these EBS volumes that are associated to the EC2 instances, right? we need to work with three different components. One is called as a PV, which is a physical volume. One is called as a VG, which is the volume group, and the other one is called as a LV, which is the logical volume, right? We'll see this. First of all, whenever you get a volume to your EC2 instances, you have to decide the volume you would like to use as it is as a single file system, then you format it directly, or you would like to divide the volume it into the partitions, then you create a partition and you format the partition itself. No, I wanted to use these volumes as part of the logical volume management. Then the each volume that you would like to use within the logical volume software management, right? Those volumes has to be created as a PV, right? PV in the sense the physical volume in the sense from the LVM long-ways perspective, the PV in the sense I'm just converting my volumes that are associated in my EC2 server level it into the logical volume management compatibility structure. You see, when I create my volumes into the physical volume, now these volumes are ready to start using within the logical volume management. That's how the first step is you need to create a PV, guys, right? PV in the sense a physical volume has to be created, right? Once the physical volume is created, then your volumes are ready to start using within the logical volume management concept, right? The second step is you need to create a volume group. In a sense, whichever the physical volumes that you created, those physical volumes now has to be added it into the group. A volume group can have at least one physical volume, or a volume group can be extended to a multiple volumes as well. You see, in this scenario, first I created a volume group with one physical volume. Later, I'm extending my volume group by adding a few more physical volumes to it. Whenever you create a volume group having the group of physical volumes within it, the size of the volume group will be equivalent to the sum of all the different volumes that are added to the volume group. Okay, you see here like the 100 GB, 50 GB, 200 GB all together it will be like 350 GB space, right? So when you are adding all these volumes it into the volume group, right, the size of the volume group will be equivalent to the sum of all these physical volumes. So now if you ask me what is the size of the volume group, the volume group of size 350 GB. Of course, the volume group is just a logical grouping of these different volumes. That is not a real physical space. The real physical space is actually your SDC, SDD, SDB volumes only. But logically, it is grouping those volumes and giving you a sum of all these different spaces it into one single bigger volume, which is called as a volume group. Then once you get a volume group of 350 GB, now you start creating a logical volume. When you are creating a logical volume, the logical volume size can be anything that you like it, but definitely not more than 350 GB because the whole total capacity itself is having 350 GB with you, right? The combination of all these three different volumes, right? You can create a volume not more than 350 GB in size. Let's say I will create a logical volume of 150 GB. If I create a 150 GB logical volume, what will happen? Right, this logical volume will be get created by using the 350 GB space of your volume group. Technically speaking, when you create a 120 120 GB volume, logical volume, the volume group will take a decision. This 120 GB has to be provisioned by using which physical volumes behind the screens. Possibly, it may give you 100 GB from SDC, 20 GB from SDD, or it may give you a the 50 GB from SDC, 50 GB from SDD, 20 GB from SDB. It's up to the logical volume management software, right, to provision the required 120 GB capacity from these volumes. It can be come from one single volume, or it can be come from multiple volumes, right? So because when you are creating a logical volume, you are all telling that, hey, I need 120 GB of volume, right? Let the LVM take care of provisioning this 120 GB capacity from any of the different physical volumes that are available behind the screens, right? Inside your volume group. Good. That way, you can create a multiple logical volumes of your desired sizes. You see now, I can create a one more logical volume with 40 GB. I can create a one more logical volume with 190 GB. It's up to you what kind of the sizes that you can, create a logical volume, right? So indirectly, yes, all these logical volumes are actually using the spaces from your physical volume only. But the advantage that you get it here is you don't need to worry about a actual physical volume sizes. It could be in any size, right? Combiningly, you are creating your own required logical volume size, and that logical volume will be formatted and created as a file system. That way, you see now, I can create a file system of 120 GB, 40 GB, 190 GB as well, though there is no physical volume available behind the screens meeting to your criteria, right? So that is what is the logical volume management concept. When you are creating a physical volume, your physical volume will be get divided it into the number of portions, so that your volume will be compatible in using within the logical volume management. When the PV gets divided it into the number of portions, right? Then the each portion is called as a physical extent. Physical extent is the terminology that we use here to the each portion that is created within the PV. Sometimes the physical extent size may be, let's say, a 64 KB, 128 KB, or you can customize whatever the size that you like it, correct? So your whole size of the volume will be get divided it into a number of portions, and each portion is called as physical extent. There will be some default size will be chosen to create a partitioning there, right? Like a portions, right? So when you are creating a logical volume of your desired size, even the logical volume also will be get divided it into the a number of portions. Each portion is called as a logical extent, right? So technically speaking, let's say each physical extent is of 64 KB in size, right? Now, if I need some 50 GB, it will calculate automatically to give you the 50 GB capacity, how many number of physical extents would be required, right? So when you are creating a logical volume of 120 GB in this case, it will calculate to give you 120 GB space, how many physical extents would be required. It will calculate, the LVM software will be allocating the number of physical extents to your logical volume. That means the LV is now going to map with your physical extents that are created in your the physical volume level, right? Sometimes, in order to give you this 128 GB, the 100 GB capacity equivalent to number of physical extents will be taken from SDC. The 20 GB equivalent number of physical extents will be taken from SDD. All together, all those physical extents will be mapping to your LV. That's how backend it is going to create a LV for you, right? So for you, it's all about creating a logical volume of required sizes, and you format it and you store the data in the LV. But right, technically, you are not keeping the data in the LV. Your data will actually go and sit into your specific volume only, maybe a SDC, SDD, SDB, but all those volumes are behind the volume group level. You at a front end, you always work at a LV level. The backend, it always mapping this LV to the corresponding physical extents. Then the data will be get stored on the mapped physical extents only. Well, let's see how exactly it works when it comes to the implementation, guys, right? So as of now, you have understood that the logical volume management is a concept of making it flexible to create your own size of the file systems irrespective of the size of the physical volume that are allotted for your EC2 instances, right? With the help of the volume group and logically you are able to make use of the total volume space together into your logical volumes, right? Let's few of the commands that are involved here in terms of using the logical volume management. Let's say I have the EC2 instance here, right, in my AWS management console. Let me logging into this EC2 server in order to show you the logical volume management concept, because ultimately my goal is to create a file system, but I'm just creating a file system in a different way using the LVM concept today, right? So let me logging into the EC2 instances. As of now, I can see that the EC2 instance has a default root volume. The default root volume having one partition. That partition is mounted on the slash file system. That means any data, any file and directory that you create in the system, definitely that data is belongs to the slash file system, which is XVDA1 partition. That means the data will be get sit in XVDA volume, right? Now I wanted to have my own file system to keep my data so that the data will be sitting in the different set of volumes, right? So what I do, I will go back to the AWS. Let me start adding a few volumes to that. My server is in 1B zone. So obviously I need to start creating the volumes in the same zone only in order to start attaching the volumes to the server, right? Let's say I'll take one volume of 5 GB in size, right? Of course, in the presentation, I have been told 200 GB. Why should I be using 200 GB just for implementing the stuff, right? Because the bigger size, billing also will be high, right? So I'm just taking a minimal size, let's say 5 GB in size in 1B zone. Let me create a volume, right? Now let me create a one more volume. Maybe this time I'm creating the volume of, let's say, 7 GB in size in 1B zone. Let me create a volume. Let me create a one more volume, right? Let's say this time I'll go with a no, little bigger size, maybe 15 GB of volume. I'm creating it in the 1B availability zone. Create a volume. Now let me attach these volumes to the EC2 instances, correct? Let me go to attach a volume, select the EC2 instance from the drop down. Let it be a auto created naming standards, not a worry. Attach a volume. Now let me select the second volume. Let me attach the second volume as well to my EC2 instance. Select the instance from the drop down. Attach a volume. Now let me choose the third volume and let me attach this volume to the EC2 instances. Let me choose the instance from the drop down. Let me click on attach volume. Good. Now if I go back to my server, if I run lsblk, you see that I have got three volumes of different sizes, 5 GB, 7 GB, 15 GB. Now let's say guys, I wanted to create 20 GB of file system, right? So I can't use any one single disk here to create a 20 GB file system, right? Right? So I can't use the volume directly, and even partitioning the disk also will not help because I'm trying to create a file system of a bigger size than the actual volume. That is where I can make use of the logical volume management concept, right? So, so the first step is we need to create a physical volume, right? The PVS is the command to see the list of physical volumes that are available. The physical volume in the sense, the volume that is compatible to use within the LVM control, right? So Let me run lsblk one more time just to see the naming standard of these volumes. XVDF, DG, DH are the default names that are given to these volumes, right? PV create is the command to create a physical volume, right? PV create slash dev slash XVDF. You all know, right? The slash dev is the complete absolute path that we need to give to this device, and you hit enter, right? Now if you do PVS, you see that the volume is created as a PV, and it is stating that the size of the volume is 5 GB and completely 5 GB is now available as a free to use. Good. You can use PV display command to get more details about this particular PV, right? The PV display is showing that, right? This particular volume is of 5 GB in size. You see the 5 GB in size and the volume name and the remaining properties. So far so good. The same way you need to create a physical volume for other volumes as well, right? So let's say pv create slash dev slash xvdg, pv create slash dev slash xvdh. Now if you see pvs command, all the three volumes that I wanted to use within the LVM control are created as a physical volumes, right? As per this architecture, the next step is we need to create a volume group. I need to make them into a group, right? Let me do that, right? VG create is the command to create a volume group, and you have to specify the volume group name, right? Let's say I will call this out as VG01. It could be any name that you like it, not a problem, right? VG01 is the volume group name, and I wanted to add slash dev slash xvdf volume, physical volume within the group. Once the VG is created, you can run VGS command to see the VG properties, right? It says that the volume group name is VG01. This volume group is currently having one physical volume, right? Now you see what is the size of the volume group. The volume group size is equivalent to 5 GB. Why? The volume that I just have added to my volume group is of 5 GB size, and your volume group size also become a 5 GB, right? As I said, it's possible to extend the volume with the multiple volumes, right? Volume group. So VG extend is the command to add additional volumes to the group, right? So let's say I wanted to add slash dev slash xvdg also to this. Now what is the size of the volume group, guys? You see the volume group is now containing two physical volumes, and if you see the size, it's close to 12 GB. Why? 5 GB plus 7 GB together, it's like a 12 GB in size. The sum of all the physical volumes will become the size of the volume group, right? So I can run the command vg extend one more time. This time I'm going to add xvdh as well. Now let me run VGS. You see it has total three physical volumes inside a group. The total size is going towards 27 GB, which is the sum of all these three different physical volumes, right? Once you make them as a group, right, what is the total size of the volume group? That is the maximum total storage capacity that you have to use to your file systems, right? Now I can start creating a logical volumes of your desired size and capacity, right? So LVS is the command to see the logical volume properties. And as of now, I don't see any logical volumes are created, right? Let me show you this command one more time. PV display. You see the moment when you add the physical volume to the volume group, right? Each physical volume is having some properties. You can see here the volume is assigned with a PE size. PE in the sense a physical extent size. That means the 5 GB of volume is divided it into the number of extents, number of portions. Each portion size is almost 4 MB in size. Like that, every physical volume is divided it into 4 MB equal partitions in it, right? That's happen automatically when you add a volume to the VG level, right? Now, when you create a logical volume, how much size of the logical volume that you are creating, it automatically consider this many number of physical extents from this. We can see here that the each physical volume, right? This 5 GB volume is divided it into total 1279 PEs. I'm sure the 1279 into 4 MB is equivalent to the 5 GB size, right? So that's how it is divided it into. The total PEs are currently free. You see free PE. Why all are free? Because we are not started using any one of the physical volume yet. So all the PEs are currently in free state, right? Let me go and create a LV, guys. LV create is the command to create a logical volume. Hyphen N is the flag to specify the name of the logical volume. Whatever the name that you like, it can give it over there, right? And you need to specify the volume group name, on which volume group you would like to create a logical volume, right? VG01 is the volume group name where I would like to consume the space, right? And you need to specify the size, right? What is the size of the logical volume that you would like to create? Let's say I would like to create 2 GB of logical volume. You can give any size, not a problem. Giving more size will take more time for execution. So I'm just taking lesser size for understanding the concept, right? Let's say I'm trying to create a 2 GB of logical volume and you hit enter, right? You see that the logical volume is created. The LVS command showing that the logical volume is created. The volume is created in the VG01. The logical volume size is 2 GB. Good. Now if I run PV display command, right? The PV display says that, you see guys, in the /dev/ svf disk, right? The total size of the disk is 5 GB. The PE size is 4 MB. The total partitions are created as 1279, and you see free PE 767, allotted PE 512. That means 512 number of physical extents from this disk is now allocated to the logical volume that you created. If you do the calculation, 512 PE into 4 MB size, I'm sure that is equivalent to the 2 GB. That means to get a 2 GB space to this logical volume, how many number of physical extents would be required? It automatically calculates that many number of physical extents are reserved now. That's where it is saying the allocated PE, right? Whichever the PEs are allocated to this logical volume, whenever you store some data in this logical volume, that data will actually be storing into these allocated PEs on this particular hard drive only, right? That's the mapping will be done automatically behind the screens, right? So when you run LV display command, right, it will give you more details. You see, the logical volume is created in the volume group, right? The LV path will tell that the LV is created in which volume group, the volume group is in which location. That's how the complete absolute path of the logical volume that you created will be /dev/ volume group name /LV name. This is the complete path, guys, just to understand that the LV is created in which volume group, right? If you do little scroll down here, we see the logical volume is created with 2 GB in size. The current LE logical extents, right? You see 512. That means 512 into the 4 MB, which is the size of your physical extent, is equivalent to 2 GB, right? That's how you get some more information how the LV is created, guys. Well, so now once the LV is created, now we can start using this LV to start formatting it and to create a file system, right? All what you can do, right? mkfs -t, the type of the format, the LV name, always we have to specify the LV is in which volume group. Always we have to specify the complete path that starts with dev, and you hit enter. Now this is the LV path that I'm using to create a file system, guys. Right now the file system is created. You can mount this file system on any directory that you would like to. Create a directory and can start mounting it. Right? Mount LV path slash data df-h. Now you see that I am able to create a file system with a 2 GB in size on your logical volume. Like that, whichever the size of the file system that you like, it can easily go and create it now, right, without having any dependency with your volume sizes, because all the volumes are grouped into a volume group, right? So how much space is available in the volume group, that much of the bigger file system can be created. You see now the sum of all the physical volumes is equivalent to a 27 GB, right? The volume group size is 27 GB, and you see how much is free, 24.99. That means what, right? Close to 25. Why? 2 GB logical volume is already created. That means out of total 27 GB availability, 2 GB space is reserved for a specific logical volume. Hence, it is showing that only the remaining is freely available, right? Like that, we need to verify how much free space is left in your volume group and start creating a logical volume, so that the LVM software will take care of mapping your logical volume size to the required no, physical extents of your physical volumes behind the screens. It can be scattered as well. When I say scattered, sometimes possibly it may give you some portion of the space from one disk, some portion of the disk from another disk as well. It will maintain the record, right? Which volume is storing the data it into which physical volumes. That means if you go inside a file system, when you start putting the data, possibly your data may be get stored in, some data may be in one disk, some data may be in one another disk as well. Possible. For you, it is a single file system. In the backend, your data may be storing into multiple disks as well, if at all your volume space is reserved from a different disks from the mapping perspective, right? That will be taken care of. Let's say I'm creating one more volume, right? LV create hyphen n LV02, and I would like to create, let's say, 5 GB volume, right? And the VG name. Now you see the VG command. You see the available space in your volume group is reduced by another 5 GB, because the 5 GB space is allocated for this particular volume group. If you do PV display command, right, you see in this physical volume, guys, yes, 512 is allocated, the remaining are free. If you see the second physical volume, guys, the allocated PE is 1280. That means to the second logical volume that I created, it has used the space from the second physical volume, and this much of space is allocated and the remaining are free, right? The third volume is not at all in use. So it's up to the volume group to accommodate the required size from the backend volumes, right? It will automatically takes care of, right, mapping the required size from the physical volumes, right? Let me clear the screen, right? When you are creating a logical volume, you see this time I created a logical volume of 5 GB in size, right? The last step is doing the mount process. In the sense what? How will you be using this 5 GB space to start putting the data in it, right? The step number one, you need to format it as we discussed, right? The format in the sense, whatever the space that is reserved, let's say 5 GB space is reserved, right? That space will be get formatted it into the number of blocks to create it as a super block structure, right? So LV02, right? So mkfs is the command to create a part, sorry, to create a structure in the provided space, like a super block creation. You can see that This particular 5 GB logical volume space is divided it into the number of blocks, right? And the super block is created, right? The block groups. We talked about the super block structure, right? The inode structure, right? The data block. That kind of a structure will be get created in your specific logical volume that you would like to use as a file system, right? Once that structure is done, in order to start using that, right? As you know, right, by default the Linux architecture will allow you to create a file or directory inside any of the directories only. I can't create a file directly on the logical volume. That is where I need to create any directory, right? Create a directory, then you start mounting the directory on the volume. Mounting in the sense that directory is now associated to the specific device, storage device, or a volume, or a logical volume this time, right? And what is the size of the logical volume? That is the size of your slash app file system as well. Now, inside the slash app file system, you can start creating any number of files. All those files are actually storing into the corresponding storage device. That's where this particular mount point is mounted. That is the way how you guys are able to create your own data into the corresponding storage devices where this mount point is associated, right? Good, right? So that means as an a summary here, what I'm doing, right? Whenever I give you the list of volumes, in order to start using them into a logical volume management concept, first step you create them as a physical volume. Second step you add them into the volume group. Third step you create a logical volume of your required size. Then you format the logical volume and mount the logical volume into any of the mount points, right? Then start using that mount point to start storing the data in it. One advantage that you get it here, right? Let's say once you create a file system, right? Let's say the slash data is the file system of 2 GB in size. That means we can keep maximum of 2 GB data only inside the slash data, right? So for any reason, if you would like to increase the slash data size, if you want to increase the slash data file system size, that means we need to increase the LV01 size, right? The logical volume size has to be increased. Then only the file system can be increased, correct? So the step number one, you just need to verify whether my volume group is having any free space or not. If there is a free space, yes, I can do that, right? LV extend is the command to extend my logical volume size, right? Specify the logical volume size. I mean to say the size of the, sorry, the name of the logical volume. Let's say LV01, right? Specify the size, how much that you would like to extend. Because I'm extending, let me give plus. Let's say I wanted to add another 2 GB, right? And in my, sorry, I can give the complete name here, slash dev slash vg01 slash lv name. The logical volume is now extended for another 2 GB in size. If you see LVS, the LV is extended to 4 GB. If you do VGS, I'm sure comparing to the previous VGS output, another 2 GB is now less. You see the free space, now it is like 2 GB less comparing to the previous. Why? Another 2 GB is consumed and allotted for your logical volume. Your LV size is increased to a 4 GB in size. You see, the LV size is increased to 4 GB, but your slash data file system is still representing that 2 GB. It means that the LV size is increased in the sense LV started using few more physical extents from your physical volumes, right? Equivalent to the 2 GB in size. If that extra 2 GB has to be get reflected in your slash data file system level to start using that space to start storing the data, then we need to run one more command, that is resize to fs. Resize to fs is the command to resize the space, extra added space at your logical volume level, right, to your file systems. specify the LV name and you hit enter. Now you see that the slash data is increased to the 4 GB. As I said, you can't see the 4 GB. You can see at least some MBs less. Why so? As you know, right? Every time when you are creating a file system, it will use some metadata of the file system in the super block. To store the data about the file system in the super block, it has to use some space within the volume, right? So some space will be less, right? And that is the usable space. That's how you guys can increase the file system as well within the LVM control. That means when I give you a volume to you guys, right, you can directly format a volume or create a partitions, or you can make that volume into a LVM level, and you can create a logical volume by using the LVM concept as well. Whichever is flexible, can use it. At end of the day, right, you go through any process, right, and at end of the day, you have to create a file system and start using the data on the mount point where it is exactly mounted on. You may be asking here, right? Let's say I wanted to create a file system of specified size, could be a 100 GB or 150 GB or 250 GB. Why can't I create a same size of the volume from my AWS side and directly use it as a volume? Why should I be struggle in adding them into a volume group? All those things possible. I'm not denying that. That's the reason nowadays whoever is actually using the cloud as the infrastructure provider, because the cloud is giving you the flexibility to create your own size of the volumes, whichever the size of the volume that you need, can create it there and use it directly, right? And you can even can go and increase it as well, right? So nowadays, because of the cloud nature, you don't need to worry about using the logical volume management concept to create a file system of your desired sizes. But previously, when it comes to the on-premises infrastructure, on-premises in the sense what? You have purchasing your own volumes, right? Your own infrastructure. Today, let's say I purchase 100 GB volume. I can't change the capacity just like that, right? Once you purchase a physical volume at your own data center. So that is the case where the logical volume was more useful, because you may get any size of the volume, but using the LVM concept, you can take care of what is the size of the file system that you need it by adding them into the group level, and can split that space it into a multiple file system. It means that if you guys are using the cloud infrastructure, I'm sure you need not to use the LVM concept. You directly take the required size of the EBS volume and mount it as it is. But if you are on the on-premises, you don't have a flexibility to create the required size of the volumes, right? You already got some volumes with a higher capacity, but you wanted to split that into a number of file systems. That is where you need to use the logical volume management. That means I'm sure only the on-premises environments are mostly using this logical volume management concept. Whoever is in the cloud nature, no need to use this logical volume concept. You can directly take the volume, use the volume directly as a file system, as like how I have shown you in a previous lecture, right? That's a whole three different processes. How can we create a file system, right? Using the direct volume, partitions, and the logical volume management concept too, guys, right? So in the LVM model, right, we need to aware of these different commands, right? LV, yes, PVS, VGS, right? PV display, sorry, PV display, right? VG display, LV display, and I have shown you few commands like LV create, LV extend, VG extend, right? So these are the different commands that you should be familiar with, guys, right? So yeah, this is the kind of a small story, but because we already understood the file system concept, so today the goal is only to create a LV and understanding how the logical volume concept is differ comparing to the previous model, how I have created a file system, right? So that's the story for today, guys. If any questions, do let me know, or else we are good for today. And in the next lecture, I'm going to talk about the booting process of your Linux machine. What will happen when you start a Linux server, right? How the system is booting up, the booting process is involved behind the screens. I'll talk about that booting process in the next lecture, guys. Thank you.